Okay, having a look at one using our normal, CDF and PDF and inverse norm on our calculator. So in this case, we've got the heights of women are normally distributed. So there's our key factor there. The other giveaway that we're going to be using the normal distribution is the fact that we're told a mean and a standard deviation. If we were doing binomial distribution or binomial probability, we would have been given a number of trials and a probability. So that's the key red flags that, or indicators that we're going to be using the normal distribution and the factors said there. Here we've got what is the probability a woman chosen at random is taller than 155 centimeters. So I'd like to do a quick diagram and go, well, if I know that my mean is 160, I know I've got a standard deviation of 8. I'm looking at here, I've got 155 and upwards. That's the area that I'm trying to calculate. So when I go into my normal CDF, I can tell it, and these ones are great because I've got the lower and the upper, I can tell it to start at 155, and then I just have to put a nice big value in there for the upper one. So we could go a bit crazy and just put 1,000, because that's way bigger than 155. We probably could have gotten away with just putting 300 because we don't see many people that are 3 meters tall. Our mean here is 160, and our standard deviation we were told was 8. So now we can put that in and we get a 0.734. Now that makes sense looking at our diagram because we know that here's our 0.5 and we've got more than that. So always have a think about whether your answer makes sense. So we get 0.73, and if we wanted a percentage, we could change that to 73.4%. Shorter than 170. So we now have our 160 there, we've got our 170 there, and we're working out this area here. So going back in, and you could go back up here and change the numbers, like you can bring that down like that and scroll across, and you can go like between 0 and you're putting in the 170 and then the rest stays the same. So you could do it that way and get the 0.894, or you can go back into second vase and put those values in there. So I could have put like a 50 for the height or something like that. Doesn't really matter. I've got my 0, I've got my 170, got my 160 and 8 there, and we get the same answer. So you can go scroll back and bring those down if it makes it a little bit quicker for you if you're doing repeated calculations. Then the last one has what height would be put a woman among the tallest 10% of the population. So we've got our 160 there, and we want to say what will we have for that area to be 10%. Now as a decimal, that will be 0.1. So we're going to be using our inverse norm for this one. So we'll do second vase. Here's our inverse norm. We're going to put an area of 0.1. We've got a mean of 160, standard deviation of 8 again, and here we're telling it right because we want to look at the right side of the graph there. This gives us the opportunity to do, we can do left, or we can do center, or we can do right. So it gives us a lot of options. And then we do our answer, and that tells us 170.25. Now looking back at our previous answer here, when we had shorter than 170, we could see that that was 0.894. So it makes sense that that's almost 90%, that the 10% would be just a little bit more than the 170 that we worked out back there. Hopefully that helps you with your normal distribution questions.